Hello everyone. So we are going to discuss lecture number 5 of electromagnetic field theory, transmission line. This is for electronics class, electronics and communication engineering, and we are going to discuss the transmission line part 5. In this part, in previous lecture what we have studied formula for impedance, lossless and lossy transmission line. So we have studied impedance, formula for impedance, and then second we have studied formula for reflection coefficient. So these two things we have studied in previous class. Today we will study what is the formula for impedance for short circuit, open circuit, series resonance, parallel resonance. These all things we are going to study. So today we are going to study impedance, and then series resonance, parallel resonance, series resonance, parallel resonance, and series resonance, and parallel resonance. Third thing is parallel resonance. And fourth, ABCD parameter of transmission line. Of transmission line. And last thing is we are going to discuss a reflection coefficient for matching and mismatching condition. So these are the all topics which we are going to study in today class. Okay. So let's start the class by impedance. So first of all we will study short circuit impedance and open circuit impedance. We have studied in the previous class also, but I will recap that topic, short circuit impedance and open circuit impedance. Then after that I will recap series resonance. I will give the information about series resonance and parallel resonance. Okay. So first thing is we are going to discuss impedance. Okay. So first point is short circuit impedance, short circuit input impedance. This question is asked in 2024 also. Impedance, short circuit impedance. What will happen? There is a transmission line of length L. It may be lossless or it may be lossy. So of length L there is a transmission line and there is a load ZL and characteristic impedance Z0. The length of the transmission line is L, okay, and ZL is short circuit, that means 0. So what is the formula for in case of lossy transmission line? In case of lossy transmission line, what is the formula for that? So in case of lossy transmission line, we have the Zn formula, Zn in terms of hyperbolic function. So in case of lossy transmission line, the formula of Zn is in terms of hyperbolic function. So Zn is equal to Z0 ZL plus Z0 tan hyperbolic gamma L and divided by Z0 plus ZL tan hyperbolic gamma L, and I will put ZL is equal to 0. You will get ZL is equal to 0. You will get Zn. So Zn will be called as ZSC Z0 and 0 plus Z0 tan hyperbolic gamma L and Z0 plus 0. So this Z0 and this Z0 will be cancelled out. So ZSC formula will be Z0 tan hyperbolic gamma L. This is the formula for ZSC. Second thing is for in case of lossless transmission line. In case of lossless transmission line, what will happen? Lossless transmission line Zn formula will be Zn is equal to Z0 ZL plus JZ0 tan beta L. Yes sir. And divided by Z0 plus JZL tan gamma L, beta L. I'll put ZL is equal to 0. So Zn will be equal to ZSC Z0 0 plus J Z0 tan beta L and divided by Z0 plus J0 plus J0. This Z0 and this Z0 will be cancelled out. So short circuit impedance formula, input impedance formula is JZ0 tan beta L. Okay, so these are the points which they are going to ask. For different types of length, they have asked in 2024 short circuit impedance, means length lambda by 8, lambda by 4, 3 lambda by 8, and second case is at lambda by 2. So they have asked this question. Okay, so this is short circuit impedance. Then after we are going to study open circuit impedance. Open circuit impedance is open circuit input impedance. Open circuit input impedance. In case of open circuit input impedance, there is a transmission line and it is open circuit at one end. It is open circuit at one end. So here ZL is equal to infinite, and at this case the Zin will be called as ZOC. So in case of lossy transmission line, Zn will be equal to Z0 ZL plus Z0 tan hyperbolic gamma L and Z0 plus ZL tan hyperbolic gamma L. But what will happen here? Here ZL is equal to infinite. So I have to take ratio because it is infinite is to infinite. So I will take ratio. So Zn will be equal to ZOC will be equal to Z0 upon Z0 or Z0 1 plus Z0 by ZL tan hyperbolic gamma L and Z0 upon ZL, Z0 upon ZL plus tan hyperbolic gamma L. ZL is infinite, so it will become 0. This will become 0. So our function will be ZOC will be Z0 upon tan hyperbolic gamma L, that means cot hyperbolic gamma L. So this is the formula for lossy transmission line. In case of lossy transmission line, ZOC will be like this. Then in case of lossless transmission line, in case of lossless transmission line, tomorrow we will discuss questions only. Okay, so in case of lossless transmission line, ZSC is equal to Z0 ZL plus JZ0 tan hyperbolic beta L divided by Z0 plus JZL tan hyperbolic beta L. I will tan beta L. So I will take ZL common so that I can apply limit. So I will take ZL common. So Z0 1 plus Z0 by ZL tan beta L J divided by Z0 by ZL plus J tan beta L. At ZL is equal to infinite, this ratio will be 0 and this ratio will be 0. So it will be Z0 1 by J is minus J. So minus J Z0 cot beta L. So this is the formula for open circuit. This is the formula for open circuit. So we have derived short circuit impedance, and for lossy and lossless we have derived for open circuit impedance, for lossy and lossless. Then we are going to derive the relationship between ZSC and ZOC. So in case of lossy transmission line, what will happen? So in case of lossy transmission line, ZOC is equal to JZ0 cot hyperbolic gamma L and ZSC is equal to Z0 tan hyperbolic gamma L. So if I will multiply this ZSC and ZOC, what will happen? So if we will multiply ZSC into ZOC, you will get Z0 square, because tan and into cot is equal to 1. So our Z0 will be equal to under root ZSC into ZOC. So this is the formula for in case of lossy transmission line. In case of lossless transmission line, what will happen? In case of lossless transmission line, the formula will be same. So in case of lossless transmission line, in case of lossless transmission line, ZSC is equal to JZ0 tan beta L and ZOC is equal to minus JZ0 cot beta L. Yes sir. So we have ZSC into ZOC, J Z0 tan beta L into minus J Z0 cot beta L, tan beta L into cot beta L 1, J into J minus J square. So minus J square into Z0, minus J square is minus 1, so minus 1 into Z0. So it will be Z0 square. So what will happen? Z0 will be equal to under root ZSC into ZOC. So this is the formula for open circuit and short circuit impedance. This is the formula for open circuit and short circuit impedance and Z0. This is the relationship. Then we have different types of length. I am going to discuss about different types of length for lossless transmission line only. After that I will discuss only for lossless transmission line. So for lossless transmission line, different types of length are present, and this question is asked in GATE exam in 2024, like that. So we have 0, length will be 0, that means 0 length I am considering. So in that case beta L will be equal to 2 pi by lambda, and 2 pi by lambda into L 0, so it will be 0. So ZSC will be equal to, beta L will be equal to 0. That means ZSC will be equal to, ZSC is equal to ZZ naught tan beta L, and beta L is 0, so tan is 0, so it will be 0. ZOC will be equal to minus JZ naught cot beta L. Beta L is 0, so cot 0 is infinite. Okay. So this is short circuit and this is open circuit. So at load it is short circuit, at load it should be open circuit. Then we have length L is equal to lambda by 4. So in this case beta L will be equal to 2 pi by lambda into lambda by 4. It will be pi by 2. So in this case ZSC will be equal to JZ naught tan pi by 2. Pi by 2 is infinity, so it is infinite. ZOC is equal to J minus JZ naught cot beta L. Cot pi by 2 is 0. So here it is short circuit becomes open circuit and open circuit become short circuit. So this is the point here. So at lambda by 4 impedance inversion occurs. That means short circuit become open circuit and open circuit become short circuit. Then so here impedance inversion occurs. So they will ask when impedance inversion occurs, so you will say at the length of lambda by 4 or odd multiple of lambda by 4. So in case of odd multiple of lambda by 4, the impedance will get inverted, and that means short circuit become open circuit become short circuit, capacitive become inductive become capacitive. So that means in that way you can say that. Third is length lambda by 2. In this case beta L is equal to 2 pi by lambda and length is lambda by 2, so it will be pi, and tan pi is equal to minus 1. So tan pi is equal to 0, so tan beta L is equal to 0, so it will be 0. ZOC will be equal to minus JZ naught cot beta L. In that case it will be minus JZ naught cot beta L. In that case what will happen? In that case it will be open circuit because tan pi, cot pi is infinite, so it is open circuit. At length is equal to 3 lambda by 4, what will happen? Beta L will be equal to 2 pi by lambda into 3 lambda by 4. It is equal to 3 pi by 2. So in case of short circuit, tan 3 pi by 2 is minus infinity or infinity you can take, so it will be infinite, and ZOC will be equal to cot 3 pi by 2 is 0, so it will be 0. Then E part at length is equal to lambda, beta L is equal to pi. That means ZSC is equal to beta L is equal to 2 pi, ZSC is equal to JZ naught tan beta L. Tan 2 pi is 1, so it will be tan 2 pi is 0, so it will be 0, and ZOC cot 2 pi is infinite, so it will be infinite. So like that you will remember. So tan 0 is 0, cot 0 is infinite, tan pi by 2 is infinite, cot pi by 2 is 0, tan pi by 2 is, tan pi is 0, cot pi is infinite, tan 3 pi by 2 infinite, cot 3 pi by 2 0, tan 2 pi 0, cot 2 pi infinite. That means you can say that this is our short circuit. So at lambda by 2 the nature will be same, and here open circuit. At odd multiple of lambda by 4 nature will become inverted. So at this one is short circuit and this one is open circuit. So I can say that at 0 lambda by 2 lambda nature will be same, and lambda by 4, 3 lambda by 4, 5 lambda by 4 nature will be inverted. So from that case, from this analysis you can say like this. Okay, so sixth part is are that ZSC at length n lambda by 2, that means 0 lambda by 2 lambda, the nature will be what? 0. And short circuit at odd multiple of lambda by 2, odd multiple of lambda by 4, the nature will reverse, that means short circuit become open circuit, infinite. And open circuit at length lambda by 2, the nature will be same, that means open circuit. And at length odd multiple of lambda by 4, the nature will be opposite, that means short circuit. So you can say like this, short circuit will be short circuit, yes sir, but here it will become open circuit, here it become open circuit, and here it become short circuit. So at n lambda by integer multiple of lambda by 2 at length the nature will be same, and odd multiple of lambda by 4 the nature will become opposite. That means from pictorial diagram you can understand, okay. So I'll make it in different page, or I'll make it here. So this is our transmission line, yes sir, this is our transmission line. This is short circuit, and second one is the transmission line, which is open circuit. Okay, so at short circuit what will happen? At short circuit and at some length lambda by 4, at some length lambda by 2, at some length 3 lambda by 4, and at some length lambda. So this is the point here, yes sir, this is the point here. And after that you will understand this is our open circuit. Okay, so in case of short circuit, length lambda by 4, length lambda by 4, length lambda by 2, length 3 lambda by 4, and length lambda. Here length 0, here 0, that means here length 0. I will write x in terms of x. So here x, 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 and in this case L is x is equal to 0, x is equal to lambda by 4, x is equal to lambda by 2, x is equal to 3 lambda by 4, and x is equal to lambda. Yes sir. What will happen? So in this case this is short circuit, so lambda by 4 it will become open circuit. here it is short circuit, here it is short circuit, then open circuit, then short circuit. Means at lambda by 4 nature will opposite, then same short circuit, then open circuit, then short circuit. So here we will see short circuit. After lambda by 4 it will behaves like a open circuit. At this point it will behaves like a short circuit. At this point it will behaves like a open circuit. At this point it will behaves like a short circuit. That means at this point it will behaves like a short circuit. This length of transmission line it will behaves like a open circuit. This length of transmission line it will behaves like a short circuit. This length of transmission line it will behaves like a open circuit. This length of transmission line it will behaves like a short circuit. So nature will be opposite at lambda by 4 distance. So we can say also the voltage, about voltage. So about voltage what we can say, at short circuit there is voltage minima and current maxima. At this point voltage maxima, current minima. For in this case of open circuit, at short circuit voltage is 0, current is maximum. In open circuit voltage is maximum, current will be 0. So we can use this concept. So at short circuit voltage will be minimum, current will be maximum. In case of open circuit voltage will be maximum, current will be minimum. In case of short circuit voltage will be minimum, current will be maximum. So you can write like this. Okay, you can write down like this. In this case also we can use in case of open circuit. In case of open circuit what will happen, this one is open circuit. After lambda by 4 short circuit, after lambda by 4 open circuit, after lambda by 4 short circuit, after lambda by 4 open circuit. And in this case it is voltage is maximum, so it will be maximum. Here open circuit voltage is maximum, here open circuit voltage is maximum. In case of short circuit voltage is minimum. In case of short circuit voltage is minimum. In case of short circuit voltage is minimum and current is maximum. So we can write them like this. Then after we can write also series resonance and parallel resonance. After studying some point I will come up at this diagram and you can write it down, the series resonance and parallel resonance condition. So what is series resonance? We have to understand. In case of series resonance, you know series resonance? Yes sir, we know series resonance. What is series resonance? Series resonance. Series resonance is something like that, R, L and C. Yes sir, R, L and C. What is the impedance? So you will say impedance is R JXL minus XC. JXL minus XC. Yes sir. So what will happen in this case? In this case, if I will replace at resonance, what will happen? At resonance what will happen? So at resonance what will happen? So at resonance Z0, Z will be equal to R, because XL is equal to XC. XL is equal to XC, so Z will be equal to R, that is minimum impedance. That means minimum impedance. In network you will study like this. So this is our minimum impedance. Why it is minimum? Because it is adding up something. So this one plus this one is bigger one. If you are making this one 0, so it will be minimum value. So this is minimum impedance. And in case of this resistance, this circuit, only inductor and capacitor. In this case L and C. Okay, so Z is equal to JXL and minus XC. And at resonance XL is equal to XC. And if XL is equal to XC, what will be the Z? Z will be 0. So this is minimum value of Z. So Z will be equal to 0. So this is minimum value. So at resonance, this circuit will be replaced by, at resonance, this circuit will be replaced by resistance R, and this circuit will be replaced by short circuit. And this concept is asked in network 3 always. So at resonance, this circuit will be replaced by R and this circuit will be replaced by short circuit. That means short circuit represent series resonance. That means short circuit represent series resonance. Always try to remember, short circuit will represent series resonance. In case of parallel resonance, what will happen in case of parallel resonance? In case of parallel resonance, 9th, 8th, parallel resonance. Parallel resonance. What will happen in case of parallel resonance? Parallel resonance means we have the parallel circuit, resistance, inductance and capacitance. Yes sir. So this one is L, C and something. Okay. What is the value of Y? Y is value of Y is 1 by R. Yes sir. And J 1 by XL. XL 1 by XL and 1 by XC. So 1 by XC minus 1 by XL. Yes. At resonance, what will happen? So at resonance, 1 by XL is equal to 1 by XC. And in this case, what will happen? In this case, Y is equal to 1 by R. So this is the Y, minimum value of Y. This is the minimum value of Y. So Y is minimum 1 by R. So Z is maximum R. Z max will be R. Y is minimum, so impedance is maximum. Admittance and impedance are inversely related. So it is minimum, it is maximum. Okay. Then we have inductor and capacitor only. So L and C. So what is the value of Y? In this case, Y will be J 1 by XC minus 1 by XL. At resonance, XC and XL are equal. At resonance, XC and XL are equal. So 1 by XC and 1 by XL are equal. So we can say that Y is equal to 0. Y is equal to 0. Y is equal to 0. That means minimum value. So Y minimum is equal to 0. That means Y maximum, Z max maximum is equal to infinite. So we can say that open circuit will act as a parallel resonance. Short circuit acts as a series resonance. Open circuit acts as a parallel resonance. So in case of parallel resonance, this circuit will be replaced by, in case of parallel resonance, this circuit will be replaced by only R, and in case of parallel resonance, this circuit will be replaced by open circuit. So open circuit represent parallel resonance and short circuit represent series resonance. So here short circuit means series resonance, open circuit means parallel resonance, short circuit means series resonance, open circuit means parallel resonance, short circuit means series resonance, open circuit means parallel resonance, series resonance, parallel resonance, series resonance and parallel resonance. Yes sir. So this is the point regarding this. So PR means parallel resonance or SR means series resonance. SR means series resonance and PR means parallel resonance. PR means parallel resonance. Okay. So these are the points you have to remember These are the points you have to understand. Then we have ninth point. Ninth point is what? Sir, we have a series and parallel resonance. So how you know that when series resonance occurs, when parallel resonance occurs? Okay. So this is ZSC. Yes, sir. When length is odd multiple of lambda by 4. So short circuit will behave like when length is odd multiple of lambda by 4. What will happen? Then ZSC will be equal to infinite. When length is integer multiple of lambda by 4, then ZSC will be equal to 0. Yes. So this one is known as series resonance, parallel resonance. So parallel resonance, and this one is known as series resonance. That means there is a transmission line. There is a transmission line which is short circuit. Yes, sir. There is a transmission line which is short circuit, and length is odd multiple of lambda by 4. So it will behave like a here series resonance. Series resonance. Okay. Sorry, parallel resonance. Short circuit will behave like a open circuit, and open circuit will behave like a parallel resonance. Similarly, there is a transmission line whose length is integer multiple of lambda by 2. So in this case it will behave like a series resonance. Series resonance. Okay. So always try to remember the points. Short circuit will be acts like a short circuit. Short circuit acts like a short circuit. Same nature will be shown at length and lambda by 2, means integer multiple of lambda by 2, and opposite nature will be seen at odd multiple of lambda by 2. हाँ कर देते हैं मनीष जांगड़ा. Okay, so this is the वीक आईसाइट वाले को कर देते हैं, कलर ब्लाइंडनेस वाले को भी शायद कर देते हैं वो लोग. चलिए, तो शॉर्ट सर्किट अपोजिट इम्पिडेंस, short circuit will be seen as a opposite impedance. Opposite impedance means short circuit will behave like a open circuit, so it is parallel resonance. Short circuit will behave like a short circuit, so it is series resonance. Tenth part is our open circuit. What will happen for open circuit? What will happen for open circuit? For 10th point. So 10th point, in case of open circuit, odd multiple, so open circuit will behave like a short circuit. Yes, sir. In case of short circuit, open circuit, at lambda by 2, it will behave like a open circuit. So opposite nature lambda by 4, same nature lambda by 2. So it's 0, so series resonance, and it's infinite parallel resonance. Yes, sir. So this one is series resonance, and this one is parallel resonance. So this is the concept behind series resonance and parallel resonance. Okay. Depends upon the your criteria. If it is coding like that, it will stop charging after 100% charging, or depends upon the mobile, which type of mobile you are using, low cost mobile, high cost mobile, that depends. Designing, we can design, if it is 100% charge, then we can design like this. If it is 100% charge, we can design like this, that it will stop charging, it will stop taking input current, the impedance will shown by the mobile will be infinite. Okay, then 11th point, but that mobile will be of high cost. Okay, then 11th point, we have what we have that series resonance and parallel resonance. So then after we can make a box and we will understand like this, we can find out the resonant frequency. Okay, so there is short circuit, and there is open circuit. There is two part for short circuit and open circuit. First part is for series resonance and parallel resonance. And second part is also for series resonance and parallel resonance. So there is two types of question they will ask. Then short circuit we have series resonance, and second one is parallel resonance. Similarly, we have series resonance and parallel resonance. Series resonance and parallel resonance. Okay. Then we have second thing is short circuit series resonance. So short circuit will show zero impedance, and parallel resonance, short circuit will show infinite impedance. So in this case same impedance will be shown. In this case short circuit is saying short circuit, so length will be n lambda by 2, and here short circuit is showing open circuit, so length will be odd multiple of lambda by 2, 4, and we can write down the lambda in terms of length. So we can write down the lambda in terms of length. So here lambda is equal to 2L by n, and here lambda is equal to 4L by 2n plus 1. Then we have find out lambda, we can find out Vp. Phase velocity we know that. So resonant frequency is equal to Vp upon f, Vp upon lambda. So we know that resonant frequency is equal to, so Vp is equal to f naught into lambda, and here Vp is equal to f naught into lambda. Then we can find out lambda, wave f naught. We can find out f naught. So f naught will be equal to, in this case, if I will divide lambda, so with respect to lambda it will be n Vp upon 2L, and in this case if I will divide by lambda, so f naught will be 2n plus 1, means odd multiple of Vp divided by 4L. Yes sir. And one thing more we can write down, then the value of n. The value of n will be, what is the value of n? So in this case n will be taken as 1 2 3 4, 1 2 3 4, and in this case length will be n is taken as 0, from 0. Why I am not taking 0? Because if I will take 0, that means the length will be 0, and the length will be 0, then it is short circuit only. So I will not take length is equal to 0, because without length there is no transmission line. So I have to take n is equal to from 1, and here if I will take n is equal to 0, what will happen? Length will be lambda by 4, so there will be length, the length is existing, so we can take from 0. This is a very good point, you can remember. Second thing is, in this case what is happening? In this case what will happen? So series resonance means open circuit will behaves like a short circuit, and open circuit will behaves like a open circuit in case of parallel resonance. So here open circuit behaves like a short circuit, so length will be changed. So our length will be what? Here it is changing, the nature is changed, so length will be odd multiple of lambda by 4, and here nature is same, so length will be n lambda by 2. Here nature is same, so n lambda by 2. Short circuit, open circuit, opposite nature, lambda by 4. So open circuit, short circuit, opposite nature, lambda by 4 multiple. Short circuit, open circuit, same nature, n lambda by 2. Like that you can remember. This type of question is not asked till now in GATE exam. In ECE exam, in a certain region they have asked, so they may be asked this type of question in GATE exam. Okay, so what will happen? Then after we will go through the points, lambda, length. Then after we will go through the points. Second point is, what is the lambda in terms of length? So lambda is equal to 4L divided by 2n plus 1, and here lambda is equal to 2L divided by n lambda, sorry, so lambda will be equal to 2L by n. Then after we have a Vp, Vp is equal to f lambda, so lambda is equal to Vp upon f. Lambda is equal to, sorry, f naught is equal to Vp upon lambda, f naught is equal to Vp upon lambda, f naught is equal to Vp upon lambda. So our resonance frequency will be, so f naught will be equal to here 2n plus 1 Vp, divided by 4L, and here f naught is equal to, n Vp divided by 2L. In this case n is from 0, 1, 2, 3, so on, and in this case n is from 1, 2, 3, 4 and so on. So this is the condition for series resonance and parallel resonance. short circuit, open circuit, and series resonance and parallel resonance condition. Short circuit, lambda by 2 length. Short circuit, open circuit, opposite, lambda by 4 length. Open circuit, short circuit, opposite, lambda by 4 length. Open circuit, same, lambda by 2 length. Like that you can remember. Then you can calculate lambda in terms of length. 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 Then you know the what is lambda f naught. F naught is Vp upon lambda. So you will put Vp upon lambda. So n Vp upon 2L, and here odd multiple of Vp upon 2L. Here odd multiple of Vp upon 4L, and here n Vp upon 2L. Then what will happen? If I will ask what is the minimum resonant frequency, so I will take n is equal to 1 Vp upon 2L. They will ask minimum resonant frequency, so Vp upon 4L. Here they will ask minimum resonant frequency Vp upon 4L. Here they will ask minimum resonant frequency Vp upon 2L. So this is the resonant frequency formula. You can ask also, you can go through the, if you have studied network 3 resonance, then one more question they will ask. What question they will ask? They will ask quality factor. They will ask quality factor. So what is quality factor? So quality factor is equal to resonant frequency upon bandwidth, and also quality factor is equal to alpha upon beta upon 2 alpha. So resonant frequency, you know that, beta you can calculate, alpha you can calculate, so quality factor you can calculate, f naught you can calculate, so you can calculate bandwidth. So bandwidth will be equal to f naught upon quality factor. So this is the main question they will ask in GATE exam. So they will give alpha and beta, they will give the resonance condition, and they will ask bandwidth of that case. So in that case you can calculate bandwidth by calculating quality factor and then after calculating bandwidth. Quality factor is equal to beta upon alpha. How it came? You will study in MTech. If you study EMFT, then you will study this quality factor formula. Right now there is no need to study quality factor formula, so I am not giving you any explanation about quality factor formula. 12th question. 12th question is our, this is 12th point. So series resonance, parallel resonance is over. So we will go through the short circuit and open circuit nature. How short circuit behaves, how open circuit behaves. So we are going through the nature, how it behaves like. So this is our short circuit. We are going to discuss short circuit condition. Then we will discuss open circuit condition. This type of question is asked always in GATE exam. If they will ask short circuit, open circuit, this question surely asked. This question will be asked surely. So here first of all I will write length, then I will write beta L, because beta L is important. So here beta L, then I will write what is the value of tan beta L, because it is important. What is the value of tan beta L? Then we can write the value of ZSC. We can write the value of ZSC, and then after we can write the nature of ZSC. We can write the nature of ZSC. So ZSC, and then we will write nature of ZSC. Nature. So our first length is 0 to lambda by 4. Our second length will be lambda by 4. Second length will be lambda by 4. Third length will be 0 lambda by 4 to lambda by 2. Then after lambda by 2. Then after lambda by 2 there is lambda by 2 to 3 lambda by 4. Then after lambda by 4, 3 lambda by 4. And then after 3 lambda by 4 to lambda. And then after lambda. Then after lambda. So our length will be, first length will be 0 to lambda by 4, second will be lambda by 4, third will be lambda by 4 to lambda by 2, and fourth will be lambda by 2, and then after lambda by 2 to 3 lambda by 4, lambda by 2 to 3 lambda by 4, and then after 3 lambda by 4, and then after 3 lambda by 4 to lambda, and then after lambda. Then after we will calculate beta L. Beta L is our 2 pi by lambda into L. 2 pi by lambda into L. So 2 pi by lambda into L. If I will put lambda by 4, what it will be? If I will put lambda by 4, it will be pi by 2. If I will put lambda by 2, pi, 3 lambda by 4, 3 pi by 2, and lambda 2 pi. So this will be the length. At L is equal to 0, 0, lambda by 4, pi by 2. So beta L in this case will be 0 to pi by 2. Here pi by 2 to pi, because lambda by 4, pi by 2, lambda by 2, pi. So beta L will be lambda pi by 2 to pi. In this case pi to 3 pi by 2, 3 pi by 2, and in this case 3 pi by 2 to 2 pi. So one wavelength is completed. Then what is the nature of tan theta? In this case, first quadrant it will be positive. At this point infinite. In second quadrant it will be negative. At this point 0. In third quadrant it is positive. At this point infinite. In fourth quadrant it is negative, and in fifth point it is 0. Tan 2 pi is 0. So it is very easy. First quadrant positive, tan theta is positive. Second quadrant tan theta is negative. Third quadrant tan theta is positive. Fourth quadrant tan theta is negative. Pi by 2 0, pi 0, 3 pi by 2 infinite, and 2 pi 0. Tan theta you know that. So ZSC will be equal to, so we know that ZSC is equal to JZ naught tan beta L. Yes sir. So here tan beta L is positive, so ZSC is equal to plus JX, plus value. Here infinite, so ZSC is equal to infinite. Here it is negative, so ZSC will be equal to minus JX, because tan theta is negative. Here it is 0, so it will be 0. Here it is positive, so ZSC will be equal to plus JX. Here it is negative, so infinite, so it will be infinite. Here it is negative, so ZSC will be equal to minus JX. And here it is 0, so ZSC is equal to 0, because ZSC depends totally on tan beta L. Then after we have last point, nature. What is the nature? So plus Jx means j omega L is inductive, j omega L is inductive, and minus j by omega c is capacitive. It is capacitive. So negative j will represent capacitive, positive j will represent inductive, so plus j will represent inductive, and negative infinite open circuit, minus j capacitive, 0 short circuit, plus j inductive, and this one open circuit, and this one minus j capacitive, and this one inductive, sorry 0, so short circuit. So this type of question will be asked in GATE exam. So what is that means? That means I will write it here, at 0 to lambda by 4 it will behaves like a inductive, and lambda by 4 to lambda by 2 up to this range, in this range it will behaves like a capacitive, in this range it will behaves like a inductive, in this range it will behaves like a capacitive. That means short circuit, inductive, open circuit, capacitive, short circuit, inductive, open circuit, capacitive, open circuit. Like that you have to remember. Short circuit, inductive, open circuit. Short circuit, inductive, open circuit. Capacitive, short circuit. Inductive, open circuit. Capacitive, short circuit. Like that the nature will be shown. So I will ask, what is the nature shown by this type of transmission line? So here it will show inductive, at this point short circuit, at this point open circuit, at this in this range capacitive, at this point short circuit, in this range inductive, in this range so open circuit, in this range capacitive, in this at this point short circuit. Like that you can say. So the nature will be not only inductive capacitive, it will be short circuit open circuit, or it will be series resonance parallel resonance. So nature will be shown like that. Okay, then we have open circuit also. In case of open circuit, what will happen? Let us see. In case of open circuit, what will happen? Let us see. So here open circuit, in case of open circuit there is a cot beta L. So cot beta L will have different types of point. So cot theta is, how you can see, let us see. Okay, let us see how it will show. So nature, how it will show the nature. So here cot beta L will be equal to, so cot beta L, in this range cot beta L is positive, 0, negative, infinite, positive, 0, negative, infinite. Yes sir, this is the nature of cot beta. Then we have ZOC. ZOC is minus times of J. Always try to remember minus times of J, cot beta L. So it is minus J. Minus J means minus plus minus, minus into plus minus, then 0, then minus into minus plus, then this one is infinite, this one is positive, yes sir, so negative, this one is 0, this one is ZOC, negative into negative positive, and infinite. Yes, then we have this one is infinite, open circuit, 0 short circuit, infinite open circuit, 0 short circuit. Then we have minus negative capacitive, so it is capacitive, positive inductive, positive inductive, negative capacitive, positive inductive. So this is the cases for your understanding purpose, short circuit, open circuit nature. Then we will go for next point. Then we will go for next point. So this is our 13th point. So 14th point is, so here 14th point is, 14th point will be graph. 14th point will be graph. So graph will be something like this. So this is for short circuit. For short circuit, I am going to draw the short circuit impedance graph. Yes sir, I am going to draw the short circuit impedance graph. You know tan theta. I think you know the graph of tan theta. 12th class you have studied. In 12th class you have studied. So this is the graph of tan theta. And in this range we are asking about beta L. So here 0 to pi by 2. Beta L is 0 to pi by 2. Yes sir. Then we have tan theta. Yes sir. Then we have this is from pi by 2 to pi. This is from pi by 2 to pi. Yes sir. Then we have again pi to 3 pi by 2. Pi to 3 pi by 2. This is the graph of tan theta. Pi to 3 pi by 2. And then after 3 pi by 2 to 2 pi. 3 pi by 2 to 2 pi. So this is our beta L. Here pi by 2, here it is pi, here it is 3 pi by 2, and here it is 2 pi. In terms of length, it will be, in terms of length, 0. Pi by 2 is at lambda by 4, and this one is lambda by 2. This one is 3 lambda by 4, and this length is 2 lambda. Yes, so this is lengthwise, and after that there is a point. What point? In this case it is acting as an inductive, in this range it is capacitive, in this range it is inductive, in this range it is capacitive, and for this point it is open circuit. For this point it is open circuit. That means parallel resonance. For this point it is short circuit, 0. That means series resonance. In this point it is open circuit, so it is open circuit. For this point it is open circuit. So open circuit means it is what? It is parallel resonance, and for this point it is short circuit. So short circuit means it is series resonance. So we can say that at lambda by 4 open circuit parallel resonance, at lambda by 2 short circuit series resonance, at lambda by 4 lambda by 2 open circuit parallel resonance, at lambda by 2 3 lambda short circuit series resonance. Okay, after that I will discuss PYQ question. Tomorrow I will discuss surely PYQ question. 1 hour only PYQ question. Okay. Then we have parallel resonance. Then we have open circuit condition. Then we have open circuit condition. What is open circuit condition here? So open circuit. Okay. So in case of open circuit, what will happen? In case of open circuit, what will happen? The graph will be minus cot beta L graph. The graph is for minus cot beta L. The graph is for minus cot beta L. And minus cot beta L graph will be like this. Minus cot beta L graph will be like this. So minus cot beta L graph will be like this. Like this. So this is the graph of minus cot theta. And this is the graph of tan theta. So this graph is for tan theta. Tan beta L. Tan theta graph, you know that. And this is the graph for cot theta. Cot minus cot beta L. It is not for cot theta, it is minus cot beta L. So minus cot theta graph. Okay. This graph is for minus cot theta. Yes, sir. Second, next point is our, this one is capacitive, this one is inductive, this one is capacitive, this one is inductive. At this point it will act as a, at this point it will act like a, so at this point it is short circuit, and short circuit behaves like a series resonance. Short circuit behaves like a series resonance. At this point it is open circuit, and open circuit behaves like a parallel resonance. At this point it behaves like a short circuit, and short circuit behaves like a series resonance. And at this point it behaves like a open circuit, infinite value, so it is parallel resonance. This graph is for open circuit. Okay, so we have done so many things so that you will understand. So this is only for short circuit and open circuit. In your college you will study only short circuit and open circuit. Up to third point you studied ZSC into ZOC, ZSC into ZOC. But after that I have analyzed when short circuit, when open circuit. At odd multiple of lambda by 4, short circuit become open circuit and open circuit becomes short circuit. At integer multiple of lambda by 2, short circuit will be short circuit, open circuit will be open circuit. And in case of short circuit, the voltage will be minimum, current will be maximum, and there is series resonance. At open circuit, the voltage will be maximum, current will be minimum, and it is parallel resonance. In between that, inductive, capacitive, inductive, capacitive, and here capacitive, inductive, capacitive, inductive, like that you will understand. So in this range capacitive, in this range inductive, in this range capacitive, in this range inductive. Okay, series resonance, parallel resonance I have taught. In case of series resonance, it will be replaced by resistance or short circuit. In parallel resonance, it will be replaced by resistance or open circuit. Then I have taught you short circuit, opposite nature, lambda by 4, short circuit, same nature, lambda by 2. This is the concept behind this. Second thing I have taught you, in case of open circuit, short circuit, lambda by 4, open circuit, lambda by 2 and lambda by 2. This one is infinite parallel resonance, 0 series resonance. I have taught you like this. Okay. Then after what I have taught you? Then after I have taught you the concept behind this. Short circuit, 0, lambda by 2 multiple, you will calculate F naught. Short circuit, infinite, lambda by 4 multiple, you will calculate F naught. So open circuit, 0, opposite, lambda by 4, you will calculate F naught. Open circuit, lambda by 2, you will calculate F naught. Like that you can calculate. And from quality factor also you can calculate. The beta is given, alpha is given, you can calculate quality factor. F naught you can calculate from here, and bandwidth you can calculate easily. Then what is the nature of short circuit and open circuit? In between the length, 0 to lambda by 4, lambda by 4 to lambda by 2, and in this case, so nature will be inductive, capacitive, like that. Open circuit, short circuit, open circuit, short circuit, like that you can remember. In case of open circuit, capacitive, inductive, short circuit, open circuit, short circuit, open circuit. You can remember or you can draw the table. This is the graph for short circuit and this is the graph for open circuit. I have taught this much of things, so you can memorize also. So impedance, short circuit, open circuit we have done. So today we have done short circuit, open circuit, and second we have done series resonance, parallel resonance. Tomorrow we will go for some question discussion, open circuit and series resonance and parallel resonance. Series resonance and parallel resonance is not asked in GATE exam, but they may be asked the question in GATE exam. I have designed some question. I have designed some question I will do in tomorrow class. Parallel resonance. Okay. Then you can download Unity app. You can download and you will get this concept, this points, and after that this one is the Sonu Sir PW Telegram group. You can join to get connected with me. Thank you everyone.